Well, howdy, physics sleuths and inquisitive souls. Welcome again to Dynamic Gravity. So today, we are going to dig deep, children, into the Earth and our little rabbit hole today. So deep, we might run into some long since dead buried bodies. Dig them up. We're going to go into something that I have coined the phrase for, because it doesn't exist by modern physics, just according to me and my theory of gravity. And if you have not yet looked at my theory of gravity, you don't know what I'm talking about, please, I encourage you to look into the description below. I will post a link to my theory, and you can read it. It's only like 5 or 6 pages long, and I guarantee you after reading that, you will know more than anyone else on the planet about gravity, except, of course, me, because I am the one. So today, we're going to go into something new. And I first discovered this on my video that I did incorporating Poisson's equations with my theory of gravity is worth newtons. And the summation, the end of that rabbit hole was we came across the theory that it is completely possible to have a gravitational field with curl. And I know right now, I know it. I know you're like, what? What are you talking about? What's curl? What is this? Why is that such a deal? Who cares? What is this? Yeah, we're gonna dig deep. So, basically, there are 4 different types of fields that I've discovered so far. We have an electric field. Okay, and if we look here, go by, of course, everyone's favorite source. My favorite source helped me incredibly at Wikipedia, even though they have kiboshed me horribly. One way of stating Faraday's law is that curl is of the electric field is equal to the negative time derivative of the magnetic field. In the absence of time-varying magnetic fields, the electric field is therefore conservative, i.e. curl-free. So when I say curl, I mean curl, C-U-R-L, okay? And you might be like, well, what is curl? We're going to get to that. Just all you need to know on this particular slide is that an electric field does not have any curl, and it is hence, by nature, conservative. Okay? So, now we go into a gravitational field, the curl of a gravitational field. And long story short, it has been shown that a gravitational field is conservative and hence has no curl. We go down here, that is the gravitational field is curl-free field. So we got 2 fields we've gone over so far, an electric field and a gravitational field. And both are a force carrier particle is going to be the virtual photon, according to my theory of gravity, and both of those fields are conservative and hence curl-free. You're like, well, what does conservative mean? Well, this little diagram kind of explains it. If you have 2 points, right, point A and point B, and you want to go to point B, and so you go this way, you go left to point B. Cool. What happens if you went right? The same thing. You would have used the exact same amount of energy to get from here to there because the field is uniform in all directions going outward, okay? Where a magnetic field, on the other hand, has curl, and that is not the case because a magnetic field has poles, so the field lines are going to be going all different directions. So if you try and go from point A to point B in a magnetic field, you're going to be going through different field lines, which means you're going to be going through different amounts of energy. So it's not the same. It's different. Okay, so electric fields and gravitational fields are free of curl. They have no curl, okay? So now we're going into a magnetic field, the curl of a magnetic field. And you're like, okay, so what is curl? Okay, well, this equation leads to an expression of curl in the magnetic field. And this is, I guess, some equations. I haven't really seen these before. I guess, I don't know, maybe it looks like a Maxwell equation right there. Yeah, and they move it around, blah, blah, blah. And this is eventually where they say clearly then the curl of B, the magnetic field, B is magnetic field, is equivalent to 4 pi J divided by speed flight. Thus, the curl of the magnetic field at any point is equal to the current density at that point. All right, so basically they're saying that curl, all right, I got to explain it for you, okay? An electric field, okay, is static. It does not move. It's an electric particle that's not moving. If that particle is accelerating and moving at a faster speed, then it will now create curl, okay? There's this thing called like the right-hand rule, all right? And it's like if you have your charged particles, your electrons, let's say, going straight, then your magnetic field is going to be going perpendicular to what your charged particles are going. So you have charged particles are accelerating. Now you got a magnetic field creating. Well, guess what? That creates curl. And that's why the right-hand rule looks like this. It's like, hey, pointing at you, but with your fingers curled around. Okay? So all you really need to know is the simplest way to think of it is an electric field without curl is just an electric field. An electric field with curl is a magnetic field, which by definition is also an electric field that's moving. So if you move an electric field, you create curl, and now that turns into what we describe as a magnetic field. And the differences between the two can be pretty radical because electric fields and magnetic fields do totally different things in a lot of ways, even though they go back and forth and interact with each other. They do different things. They exert different forces. All right, and divergence of magnet, I think this means everything just goes around, has two polarities and everything. The field of lines go out one end, all come back in. They don't go out into space forever, and like an electric field does. Okay, so if you need a better explanation, here's a visual. The curl of the vector, let me move that up a little bit. The curl of a vector field does not literally look like the circulations. This is a heuristic depiction, meaning this is like a 2D thing of a 3D model. It's not going to apply right, and this is not exactly what they look like, but for your primitive monkey brain, this is the best way to think about it. If you're going to write down a piece of paper, if you're going to draw it, this is how you'd want to draw it, okay? And you can see you have your moving charged particles, your electric charge, whatever. And as it's moving, it is creating curl going around it. It's like little circles of force of a magnetic field around the electric line. And if you take just a sliver of that, then it just looks like a circle. But of course, obviously, if you were to do it 3D, it would look like a tube that just engulfs all around wherever your electric particles are going. Like if you have a wire, perfectly say, and electricity is passing through that wire current, you're going to have a magnetic field creating around that, dependent upon how much current you have going through it, if that makes any sense. All right. And of course, here are the equations, Maxwell. I believe this little symbol, the upside down triangle with the time sign, means curl. So this would be like curl of the electric field. And of course, this is like, a magnetic field over time. So if you have no time, then it is 0, which means you have no curl. So an electric field that's not moving has no curl. And if it is moving, it now has curl. There's a magnetic field. And of course, this one's saying the curl of a magnetic field can create an electric field. Okay? It's pretty deep, pretty hard to understand. I know it's not intuitive for a lot of people, this sort of stuff. It took me a long time wrestling with this to get a good grasp of it, and I'm still not perfect, but I'm getting there. Okay, so now we have, of course, we have to understand a gravitational field, all right? Because an electric field is propagating omnidirectional out in straight lines, going everywhere. And so is a gravitational field. It's the same, right? But they're different. I personally believe this has not been proven by science. And most things I tell you, I show you. Like, listen, this is proven by science. I'm not making this up. This is why I drag you along to all these websites so you know that I'm not just making stuff up. This is all legitimate physics, okay? But this particular tidbit of knowledge I'm about to drop on you is not yet approved by physics. We don't know if this is the case or not. But if this is the case, I completely understand gravity in a way that is intuitive, and it makes perfect sense to me, from the smallest, particle, atom, quark, whatever, all the way up to supermassive black holes. Everything makes perfect sense to me. I explain everything, and I can understand everything. And what that is that electromagnetic radiation, right? Like photons, okay, with hertz. They have a certain frequency. All right, so we got like gamma rays all the way down to like radio waves, microwaves, whatever, visible light. It's all photons. So they will hit an electron in an atom, because that electron is in an electron shield or a cloud surrounding the proton. So it's going to run interference. It's going to capture all the electromagnetic radiation and absorb it and go to a higher energy state and then release it. And as it releases it, shoot that out as a photon. All right. Now, I personally believe that the photons, or that means also the virtual photons, mainly as I'm getting at, are different, that are released from an electron versus from the proton, okay? I believe they're identical in every way except for one. They're of opposite polarity. And there are reasons for this, why this would make sense. Because we know that if we have two electrons, they're going to repel each other. They can't attract. They can only repel each other. That tells me they're only allowing one type of particle they're emitting that's doing the force, one type of virtual photon, and that repels same sides. And protons are the same. Protons will repel. They won't attract. So the proton is positive, and it repels from positive. So that tells me the virtual photons they're emitting are positive, where the electrons, virtual photons it's emitting, are negative. I did an episode going deep dive into virtual photons not too long ago. If you want to know more, look into that. But that's basically the summation of it. Is that if you have virtual photons coming from an electron, you have an electric field. Okay? And if you have virtual photons coming from a proton, you essentially have a gravitational field. Okay? Now, if you take these electrons, the negative entity, and you accelerate them, like we've discussed, now you have curl. All right? Now you have magnetic field. Well, according to theory then, if you were to take a proton and accelerate that, you would now generate a gravnetic field, a gravitational field with coral. And it will behave differently than a regular gravitational field, all right? There's two types of anti-gravity now that we've established according to dynamic gravity. Yes, two types of anti-gravity. We have the basic anti-gravity from a basic gravitational field, from the positive field that's emitted from celestial bodies. The celestial bodies do not collide. We've never seen two celestial bodies collide of equal size. There is some evidence of this according to LIGO. Personally, I believe they're different sizes, which would make it, possible. But if they're identical, the same size, I don't believe it's not possible according to dynamic gravity. It's just not the way it's going on. So you have two celestial bodies of equal size. They're going to repel each other with anti-gravity because they're both emitting the positive field emitted with the positive virtual photons from protons. But they're also going to be attracted because that positive field is going to be attracted to all the negative entities, like all the electrons, which all known matter has, even protons. I know it gets complicated. So basically, that's one form of anti-gravity we've established. I don't believe this is the type of anti-gravity the alien spaceships are utilizing when they do the things they do. It could be, but I don't think it is. I got a video of Bob Lazar later. You should watch this. It's going to blow your mind on how gravnetic field works. This is where I'm getting a lot of my information from and trying to piece all these things together. The second type of anti-gravity would be from, of course, a gravnetic field, a gravitational field with coral. So you got protons that are being accelerated, that are moving, and now you have a gravnetic field being created. And that gravnetic field is going to be as different from the gravitational field as a magnetic field is from an electric field. So now you're going to have a gravitational field. Instead of being omnidirectional, it's going to have poles of some sort, a positive and a negative pole. And it's going to, loop around and have curl and do different perpendicular forces according to, how much energy density you're moving around. And with that, it would be entirely possible then to have anti-gravity where you, not a celestial body, could now be levitated up in the air against gravity, like anti-gravity, true anti-gravity, if you want to think about it like that. Okay? And Bob Lazar says this is exactly what he saw when he worked on the alien spaceships in Area 51. Okay? Bob Lazar, he worked on this reactor, and this is a mock-up of the reactor. It's not a real reactor. It's not a functioning reactor. It's something he just built to show you what it looked like. The big square with an X on there, and the top is like a half-cylinder thing made of metal of some sort. If you take that top off, you got like a cylinder where you put your wedge of your element 115, which activates it, and a little particle that shoots protons. So we know how protons are swirling around like a cyclotron in here somehow. They know that much. They don't know beyond that. They try to cut in one of these and explode it, and everybody died, hence Bob Lazar being hired at Area 51. That's how that story went down. But they cut into this bad boy, trying to figure out what was going on. So there's obviously some protons that are being swirled around, and they're creating a gravnetic field. And then from this gravnetic field, they are doing a waveguide to siphon and redirect that gravnetic field to other parts of the craft where they can do various things with this. Now, you see here is a picture of where the siphon is, the waveguide. As it comes down from the ceiling, you just plop it, just stick it to the 3D sphere right here, and all of the gravnetic field is now going to be funneled through that waveguide to the other parts of the craft, just as if it were a magnetic field and you were using a waveguide for that. And you're like, well, is that really what happens with magnetic field? Yes. Here, let's go into that. Here's a typical waveguide, right? This is not really made for magnetic fields. This is just made for electromagnetic radiation, but it does have a magnetic component to it, which is why it is guided by a waveguide and not just, if it were a simple electric field. I don't believe an electric field, it can be guided by a waveguide, like a magnetic field can. Just like I don't believe there's no evidence for that, to my knowledge anyways, like a gravitational field cannot be guided in this manner as well. It would have to be a gravnetic field, just like a magnetic field can be. So this is an example. It's showing you, you know, how the various photons, whatever, traveling through a waveguide, they just get funneled through it, just like a funnel, man. Just like a funnel for photons. That's what it is. And it's got to be just the right size for the right frequency of photon that you're trying to, you know, direct, to guide. You can't just use any size. It has to be calibrated the right size and made of the specific right material. Okay? So yes, this is a thing. We've been doing this. I worked on these systems in the military long ago, satellite systems with waveguides on them. And yeah, you'd have your parabolic dish, your receiver, which would receive all of your EM radiation, and then it would waveguide it to the actual components that are actually doing all the measurements of everything of those photons. Okay, so. Here is from a university, Union University. I don't know, they're nobodies, but the point is they're a credit university. They're not going to feed you bullshit, and I just want you to know that I'm not making this stuff up. I've heard lead stops nuclear radiation. Can you shield or block magnetic fields? And they say the short answer is no, you cannot. Right here. But in reality, they lied to you. They do say the field lines, however, can be redirected. Therefore, it is possible to design a region of space relatively void of magnetic field lines because they have been redirected around that region. Note that you have not stopped them, just redirected them. The field lines still must be continuous and eventually close back on themselves. All right? So you're not stopping the magnetic field. You're just redirecting it with the waveguide. In order to redirect the magnetic field lines, we offer you offer them a preferred path. And magnetic lines prefer to travel materials that have a certain magnetic properties, mainly materials with high permeability. By placing a material of high permeability, or at least a permeability higher than the region in question, around the region you wish to shield. And they say you shield it now, but they said you couldn't, but you can. You effectively offer the field lines a better path to travel. So they're just basically saying, hey, look, you can make a waveguide for magnetic fields, all right? And all it's got to be is something that's conductive and whatever, magnetic fields. And then the magnetic field prefer to go that way as compared to just its normal track through space, all right? If you give it like a line to just siphon through and go through, it will do that if it likes that line good enough, okay? So when they do that, when they put this siphon or this this pipe, this waveguide on this reactor when it's going and it's emitting a gravnetic field, all of that gravnetic field is now funneled through that waveguide to other parts of the craft where they do various things like you know, the gravity emitters and make the craft go. All right, so now we are going to actually listen to the Bob Lazar interview where he talks about this. And yeah. Basically, it's pretty crazy. He blows my mind as he talks about it. Just watch. I'm going to have to try to do some things so it doesn't get hit for copyright. I don't know if this is copyright or not. I love Bob Lazar. And I've tried to listen to all the interviews, but he did so many of them that I missed a few. And this one is one of the ones I missed where he went into this. And this is huge. Let's just listen to what he says about. It's like 2-3 minutes.
How did you and your buddy endeavor to measure its energy output, and in what form? How did you take a look at it?
Well, like I was describing, the first time I saw it operating, all he had to do was put the lid, the semisphere, on top of this device, and it became operational. And he said, just put your hand on the top of it. And when I did, I could not touch it. It was the exact sensation of taking two like-pole magnets and trying to push them together.
Wow.
But it was just my hand approaching a metal sphere.
Now notice, this is not really possible with magnetic fields. I mean, with a magnetic field, you have a strong enough, any diamagnetic material like water, which we're made of, you can push away. But they do say later on, they throw out golf balls, which aren't diamagnetic, and the same thing happened. They couldn't make it touch the thing, no matter how hard they tried. But just notice how he compares this to a magnetic field. He says it felt just like a magnetic field, only I was the magnet, you know? I was what the magnetic field was reacting to instead of a magnet. So it's a gravnetic field. It is essentially a magnetic field for anything that has electrons, which is all matter, essentially.
Now, that in itself is shocking, because there's nothing that can do that.
In other words, you felt a repelling force, as in like a wall? I mean, you just could push on it?
I could push, starting from probably about a foot away, I could begin to feel something. And as I got closer, it got more intense. And probably at 2 to 3 inches, it was impossible to make contact with it.
And I just want you to point out something, too. So when I hear these things, what I hear is, okay, what's going on here? He's saying, I felt it about a foot away, and as I got closer, it got stronger and stronger until it got so strong, a couple inches away, I couldn't touch it how hard I tried. To me, that sounds like an R-squared fall-off rate, which means that the carrier particles for this mysterious field that he's dealing with are virtual photons, because that's what has an R-squared fall-off rate that carries force. So that's telling me that whatever this field is, it's using virtual photons as my theory of gravity says it should, if it is a gravnetic field like I believe. So,
and you could push on the top, your hands would slide to the bottom. It was a very intense field, and he had a golf ball there, and we even something moving at high speed could not penetrate the field. This was the basic gravity wave that the system produced.
Did you determine it to be a 360-degree field?
No, it wasn't.
It wasn't?
It wasn't. And
that's another thing to keep in mind, too. If it was just a gravitational field they're dealing with, it would have been 360. It would have been omnidirectional. But because it was a gravnetic field, it has polarities, and it has different sides. They're going to do different things. So they obviously were able to, only have half of it going for whatever reason, which could only be possible if it was a gravnetic field, not a gravitational field.
Again, that's something else. It's a completely directional gravity field only on the skin of the hemisphere.
Oh, my.
And it didn't appear on the base at all. And so this alone was just absolutely mind-boggling, because here's a machine doing the impossible. The next thing that I was shown, and it couldn't be a magic trick. It's my hand approaching a metal sphere. There's no room for any question there.
And what did you and your buddy discuss?
And I just thought of something real-time epiphany just right now, guys. You just saw me in action with my genius. I guess it would be possible for like two black holes to merge if they were both spinning fast enough that they were creating gravnetic fields, but with opposite polarities. So they were attracted to each other. And if it was strong enough to overcome the repulsion of the positive gravitational field, theoretically they could merge under those conditions. I just thought about that. Wow, that's woo! Gravity, man. Always something new to learn. I'll tell you what.
at that point? I mean, you obviously asked questions, or he offered information, or he just said,
well, this was the initial introduction to what was going on, and I mean, you could see it in his eyes. He took pride in showing off what they had, because the next thing he showed me was connecting it to the amplifier, and he said, "You want to see something really neat now?"
Yeah, there we go.
Yeah, as if that wasn't amazing. There is, how am I going to describe this? There's a fitting, almost like a pipe, that slides down and makes contact with the hemisphere.
okay,
This apparently, from what was described to me, is a tuned pipe, almost like
resonant.
waveguides are tuned for microwaves to pass through.
Would be resonant.
Exactly.
Waveguide.
So once this pipe is placed upon the hemisphere, the field completely disappears. So that's giving you evidence that it's now traveling through the waveguide. The waveguide goes to another extremely low.
So just know that if it was just a gravitational field, putting the waveguide on it wouldn't really change anything. But if it's a gravnetic field, because it wants to travel through objects with higher permeability for the field to propagate, a waveguide is where the whole thing is going to funnel through if you build it properly, if you have good engineering.
Large tube, probably about 2 feet in diameter, 4 feet long, and has plates, I guess is the best way I can describe it, on the outside. This is actually the emitter, the gravity emitter. There's something in between the two, which is the actual amplifier.
Hold it right there, Bob. We're at the bottom of the hour.
Okay, we're going to stop it there. Unfortunately, that's all he says about that part of the craft. When they come back from their little break, they go off on tangents, and they just go into different areas altogether. Would have been nice to learn more about that, because the gravnetic field is essentially, it sounds like the easiest way to create propulsion from gravity. At least that's the way the aliens do it. So, I hope you guys learned something from this video. Like, to me, this is all mind-blowing information. Just, unpacking and figuring out, deconstructing how these alien spaceships work, which we know are real. I know they're real. And I know the only two sources that I truly trust are Bob Lazar and Victor from Area 51. I personally believe that like 99% of all UFO pictures, videos, stories, blah, 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 are all fake. But if you ask me, two that 100% are not, it's the excerpts of Bob Lazar and Victor from Area 51. Definitely. So... Yeah, we're unpacking that, and we're trying to figure out how this works so we can, advance our civilization, with this technology, and take our place among the stars. Although, to be honest with you, I don't think we're quite ready yet. We're still trying to fight off extinction from pollution, climate change, nuclear missiles, the list goes on and on and on, comets, whatever. There's so many things that can extinct our species right now because we're just so not with it yet. People kind of suck, unfortunately. And so is our government, because they've been hiding the truth from you for the last 80 years about what they knew beyond a shadow of a doubt was a fact, that aliens are real and they're here. And another thing that Bob Lazar said when he came out originally was that in his lifetime, our government was going to get the green light to be allowed to tell us, the public, that aliens are real. And here we are in his lifetime, when he's like in his 70s or whatever. Now we got, all these UFO hearings for the last few years where the government is saying, okay, aliens are real. Here's pictures, here's videos we've taken of this from our military operations, whatever. They're real. They're real. Aliens are real, and they're here. And there's a lot of people that are still like, well, maybe it's some government misinformation. No, it's not a misinformation campaign. This is real. They do finally have the green light from the aliens saying that we can finally deal with the fact that we're not the sole people in this universe. And so here we are. Aliens are real and they're here, and I've known this my whole life, and I've been trying to figure out what this means and how their technology works, and I think I've done a pretty good job. I got a few more revelations to share with you guys later on in another video, But I think this video has been mind-blowing enough. Let's end it there. And I wish y'all a good day. And I will see you on the flip side. Adios, amigos.
Like, subscribe, submit.